Application title of my presentation: application of non-local criterion of based crack grow with necessary and sufficient conditions. This presentation will please the next. Yes, contents of my presentation we can divide roughly in three parts. This first part, you can see mechanical relation and the main assumptions for Bayesian crack model. In the second part, we consider a non-local criterion of Bayesian crack rule with necessary and sufficient conditions, and we will consider both energy and kinematic conditions of this criterion. And lastly, we will present some results of crack quasi-static rule and fracture toughness analysis. Please, the next. Please, the next slide. Yes. Thank you. Here we can show the main mechanical relation for Bayesian crack model. The relation between bond traction and crack opening at the crack Bayesian zone we can write in following matrix form. Here, Q is and U is component of traction vector and crack opening in local coordinate system, and C is effective compliance of bonds in normal and shear directions. It depends on distance to the crack tip. Sigma is the traction vector modulus in current point of Bayesian zone. And you move for the next slide. Thank you. Here are some assumptions for Bayesian crack model. First, the fracture process is localized in the crack Bayesian zone. This zone is considered as the crack path. It can be comparable with the whole crack length. Second assumption, distributed Bayesian traction dependent on a crack opening applied to the crack faces in the Bayesian zone. And third, materials ahead of the crack tip deformed together with adhesion layer without loss of air continuity. And finally, we must say what stress intensity factor in the Bayesian zone model non-zero at the crack tip. Please, the next slide. Next, not back, forward. Yeah, thank you. Here present two relations for energy condition of fracture criterion. First parameter is the bonds. Here is the rate of difference energy consumption by bonds in the crack Bayesian zone. Here G sub M is the energy parameter, the crack resistance in small zone near the crack tip. And second parameter, G-type. G-tip is the rate of difference energy release energy flux into crack tip. Regardless of form of bond deformation law, the rate of deformation energy release is dependent by this presented expression for the tip. The limit equilibrium of crack tip corresponds to fulfillment of the necessary condition, and this condition is the equality of energy release rate and the rate of energy dissipated by bonds. Here we show three cases of fulfillment of this criterion for crack with bonds of different compliance. With increasing compliance of bonds, the length from critical Bayesian zone increases. You can see that three graphs. Please, the next slide. The second condition of this non-local criterion is sufficient conditions for Bayesian zone size changing. The condition of critical bond stretching at the trailing edge of the Bayesian zone. Here we present the crack opening distribution at the end of the Bayesian zone for fixed crack length and also for three different bond components as on previous slide. Using jointly both conditions of this criterion, we obtain critical external loading in critical Bayesian zone size for limit equilibrium of crack. If compliance of bond increase, the same stiffness decreased, when critical breaching zone increases and critical external stress decreases. The same we show also on the previous slide. Please the next. Yes. Here we present both equation of this criterion, energy condition and kinematic condition. First graph presents dependence of both energy parameters depend on size of Bayesian zone and point A intersection of these graphs and the critical Bayesian zone. The second graph is dependence of crack opening at the edge of Bayesian zone. We have two-point intersection between crack opening and limit crack opening, but only one point A is real solution of this criterion. Define the critical parameter of fraction, critical size of Bayesian zone, and we can find critical value of external loaded after that. The crack will grow quasi-static. Please the next slide. And by basis of this criterion, we may formulate regimes of the crack tip in turning actual Bayesian zone advancing. We have two subcritical crack growth cases and one case is quasi-static crack growth. First type of subcritical crack growth regime. In this case, the crack length does not increase. The Bayesian zone size decreasing, bond breaking occurs at the Bayesian zone trailing edge. Second type of subcritical crack growth regime. The crack length can increase due to crack tip advance. The Bayesian zone grow without bond breaking. In the regime of quasi-static crack growth, in this case, the crack length increase due to crack tip advance and both and bonds and breaking at the edge of Bayesian zone. Please the next. Here we present the dependence critical bond stress for transition from regime 1A to regime 2 quasi-static crack growth. We present critical tensile external stress depend on bond relative stiffness. Three type of material above and bottom of crack. Here we put the three set of mechanical properties of material with dependence on critical external load corresponding to one set of quasi-static crack growth. Dependence on relative stiffness of bonds. With increasing in relative stiffness of bonds, the critical external load also increases due to the fact that in order to achieve a critical value of bond stretching at higher stiffness of bonds, a larger load is stable, required. With decreasing in relative rigidity of material from Q1 to Q3, the level of critical external load decreases due to increase the stress concentration factor at the trailing edge of the Bayesian zone. Please the next. However, we consider the quasi-static growth of three crack of equal length. We consider the three crack equal length totally filled with bonds, and initially, and with the mechanical properties of materials used in previous curves, one. Here, different bond components. Therefore, the crack, the bonds breaking and crack grow, it depends on bond components. To consider value of initial relative bond components, the fracture process begins with breaking the bonds in the center of the crack when the condition of bond limit stations is satisfied, followed by the transition of quasi-static graph growth. This graph shows the dependence of external load on the relative length of the part of crack without bonds. Please, the next. Here we present the dependence of critical bridge zone on the bond stiffness. Bond stiffness is a parameter inverse to bond compliance. We consider quantitative graph growth. In this case, critical bridge zone decrease if the bond stiffness increase, and very quickly decrease for rather small bond stiffness. If bond stiffness bridge zone rather small, and it's go to autonomy condition of crack tip. And the next slide shows the subcritical equalistatic graph growth for nonlinear bonds in bridge zone. We consider a simple nonlinear bonds. We use simple bilinear bond deformation law and consider transition from subcritical regime of crack growth 1A to regime of qualitative crack growth. We obtain what in the case of linear bonds, the critical bridge zone length is much bigger than for linear elastic bonds, and critical external stress much less. I nothing say about how we solve this crack problem, because to apply this criterion needs solve the boundary value problem, define the crack opening, bond stress, and so on. We solve all presented problem for straight crack between two infinite plates using numerical solution of singular integral equation. But information outlining of this method is out of this presentation. Thank you. Please next. And finally, some conclusions. The Bridget crack model was extended for fracture parameters evaluation of interface joint with arbitrary size of crack bridges zone. The non-local fracture criterion for quasi-static growth cracks with bridges zone with energy and force conditions was proposed and analyzed. The regimes of limit equilibrium of growth of crack bridges zone and crack were analyzed. The procedure of the non-local fracture criterion application was developed and it used for analysis of static crack growth with bridges zone. Thank you for your attention.